Alright, in this video what we're going to do is take a look at Canon 1's implementation plan. Now in the last video we covered the requirements of the Canon game as well as the design phase. Now those two documents stood for the entire Canon game, and what I mean by that is they stand for Canon 1, Canon 2, and Canon 3. We will not be changing the requirements or the design phase for any of the implementations of the Canon game. Now the implementation plan has to change for each version of the Canon game that we're going to produce, for the simple fact that each game is going to be based on a different framework that we're going to set up. The first one, simple Windows app that's going to be using the events built into Windows or built into our WinForm to handle interaction with our player, etc. Canon 2, we're going to design a very simple engine that's going to handle polling input from our user as well as setting player position, etc. And then finally, Canon 3 is going to use the XNA framework to handle, well, everything. Now, Canon 2 is going to start looking like what the XNA framework is going to look like at the end so that we can take you on a smooth transition from the window app world into the XNA world. But in each case, the implementation plan has to be different. So let's go ahead and focus on Canon 1. Sound good to you, Logan?
Yeah, sounds like a plan.
All right, so let's go ahead and bring up a whiteboard. And I think I'm going to scroll up to the top here just so I have plenty of room to write because, yes, there's going to be some writing going on. So again, we're doing the implementation plan for Canon 1. What do we need? Now, remember, the implementation plan is going to serve as a roadmap for us for the coding phase. So if we do a really good job with the implementation plan, then we should be able to sit down and code with relative ease because we've got more or less a flow structured out on what we need to do and in what order. And, just quickly looking over what we've got planned out, when we start out, what are we going to do first? Well, we're going to start out by creating our three objects, a player, a projectile, and a target. Then we need to set up some basic variables so that we keep track of things like screen dimensions, etc. And then from there, we're going to start making things move around and then slowly start adding in functionality until we have a mechanical state for the game where it's playable but without rules. Then we're going to turn around and lay the gameplay over it, if you will, to make it a playable game with the ability to basically lose at the end.
Right, where the game has a beginning, a play section, and then an ending after you lose.
Precisely. Now, how did this implementation come about? Logan and I simply sat down at the desk. We started discussing, all right, what do we need to do in order to code out this game? Even though the code is going to be two things, short and simple, we still needed a plan of attack. And so what we're going to do is present to you the plan of attack that we came up with, and this was our implementation plan. So backing back up to some of the things I've already mentioned, the first thing, we need to create three objects. So lots of writing going on. So create three objects. And these objects are going to be, hopefully you've guessed this, the player. Let me make that L look a little bit better. The player, the projectile, and the target. Now, how are we going to create these three objects? Well, once again, we're creating a simple WinForm application, so we are going to use controls that are available to us from the designer, or the design time toolbox, if you will, and one of the controls we have available is a picture box, just like you saw that we had available in the toolbox, a simple button control where we were able to select button and drag it out on our form back when we created that very simple Windows application where a button bounced around the screen. So let's just go ahead and comment that in. We're going to use a picture box. What's a picture box do? Well, it allows us to load a graphic in it, and we're going to need a graphic for the player, for the projectile, and for the target. So, excellent. After we create these three objects, and we'll just create them anywhere on the screen, no big deal. We'll handle setting things in code. The next thing that we're going to want to do is define some game variables. All right, in this case, let me write it like this. Define constants. Whoa! What are you talking about? We talked about variables, but we didn't really talk about constants. Constants are really nothing more than a special kind of variable The variable acts just like you've seen before, where we can have a specified type, an integer, a float, whatever it may be. But here's the kicker. It's constant throughout the application's execution time, meaning that we set it and it cannot be changed. And think about it, there are some things in just about every game that you're going to want to define and have that definition stay throughout the game. In our particular case, we're going to lock our screen dimension so that we can't change it around. It's going to be a lock size. So we want to go ahead and start out with screen dimensions.
The other handy thing that allows us to do is to later check these screen dimension variables when we need to tell if something's off screen or not. This gives us a very easy to check value.
Well, you just check this one constant as opposed to actually polling for the screen dimensions every single time, which would be, ooh, that'd be bad, wouldn't it?
It would be slower because it has to interface with the window, get the actual Windows dimensions. Whereas if we hold this value in just a simple variable, it's actually faster.
Next, projectile speed.
The reasoning for this one was more so just to have the projectile speed accessible as a name and also make it easier to change. For example, let's say we had, just in a theoretical case, if we had multiple places in code that referred to the projectile speed, of course the projectile itself, but this would make it easier to find. Instead of digging through code to look for a number that represents the projectile speed, we could look for the word projectile speed, and it just makes the code easier to read.
Exactly. I mean, if we wanted to change it quickly, we just go to one place.
Exactly. We just go to where it's defined, and it's very easy to change.
Precisely. So there may be some other variables that need to get set up, but once again, when coming up with our implementation plan, Logan and I were sitting there, and we simply came up with these three as, well, these are probably going to be pretty important. The final one that I wrote up there was the base target speed. Kind of think of this as our starting target speed. Remember, we said the target starts from the top center of the screen and is going to move in a random direction, left or right, and proceed down with the goal of striking the bottom of the screen. And, of course, you as the player have to try to hit it. Well, we need to start out with a base speed. Now, this base speed is not going to always be the speed of the target, because in our rules we define that if a projectile comes into contact with the target, basically we've just destroyed the target. Now we need to be a little bit faster. So we need to use our base target speed along with something else that's going to give us a faster speed, because we've now, I guess you could say, advanced in the game, right?
Right. It also makes tracking the speed throughout the game a little bit easier, because we don't just keep adding on to speed. We can use a simple mathematical formula to determine exactly what the speed should be at any given time.
Exactly. Next thing we need to do, after we get just a few of these, so now we've got three different picture boxes set up on the screen. We've got some constants defined. They're going to be pretty important. So at this point, let's go ahead and have a little bit of fun. Let's make the player move along with the mouse. So when we start coding this, this is what we're going to actually do. We're going to make player, let's find this, there we go, player move with mouse. Just so that we see something actually functioning. Get our player locked to the bottom of the screen, move the mouse left and right, and the player will actually move left and right. Move the mouse up and down, player doesn't care, only goes left and right. Alright, so once we have the player moving with the mouse, now what would be nice would be to see our target move and our projectile move. For these guys to move, we're going to need a timer in place, and the timer, through each tick, is going to handle updating the position of our target and our projectile. That basically making them move. And Logan, feel free if you'd like to add anything while I write this in. And if you don't have anything to add, that's cool too.
The only thing I could think of is the addition of two more variables, because here's what I was thinking. We've got our constants defined. I was just thinking of throwing down variables that represent how fast the target is moving at any given moment.
Yeah, I gotcha. That's okay in the implementation plan. We'll throw that in when we start coding.
And we've got the major points down. We've got, because the constants like screen dimensions and projectile speed, those are the baseline foundation for how the game works.
Exactly. All right, so now that we got a player that moves around, we've got a target that's moving automatically, we have a projectile that's moving automatically, and it's going to be interesting too. I mean, so here we go, drawing out our screen again. So basically at this point we'll have dropped down a random picture box somewhere else, and then we'll have our player, which we're actually going to snap down here to the bottom and get hooked up with the mouse so he moves left and right. Once we put a timer in place, which way does our object need to move? Well, to start out with, we're simply just going to make it move down. Which way do we need to have our projectile move? We're simply going to make it move up. So when we start the game, what are we going to see? Target goes tick, 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 gone. He doesn't wrap back around. We haven't implemented anything to make him wrap back around. What happens to our projectile? Tick, 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 gone. So off screen he goes, okay? So that's what's going to happen. And so we'll be able to move our player back and forth. He's going to be kind of lonely because our two other objects are gone. So once we get that in place, now we need to go ahead and get a framework set up. So go ahead.
One thing, where it says add a time, just put an R.
R. Oops. Add a timer. Well, just for that, he also gets a happy face. All right, so now that we got a timer in place, now what we're going to do is create skeletal methods. And we did this with the Hyperion project, where if you recall, when we laid out the implementation for that engine, we did the exact same thing. We talked about what kind of functionality did we need within our objects. Now, this is a little bit different here with the way this is being designed because it's a WinForm application and we're not defining all of these different objects that we're putting functionality within. In this case, we're just defining our own custom methods within the form itself. So, let's go ahead and just put in create. And these will all make sense as I throw them in. Skeletal methods. All right, create skeletal methods. First of all, what I'd like to do is focus on our gameplay methods. We're going to divide these up into, 3 different areas. So we've got gameplay methods. And in gameplay methods, what do we have? We have things like fire projectile. And what does fire projectile do? Basically, it checks to see if we can fire, because remember, we set down rules about the ability for us to fire. We're only allowed to have one projectile on the screen at a time. So we need to check to see if we can fire, and if we can, do so. So the fire projectile is going to handle that. Well, that brings us right into another interesting one. We need to be able to reset 2 different things. We need to be able to reset our target, and we need to be able to reset our projectile. Remember, fire projectile is going to check to see if we are allowed to, shoot off another projectile. We need to be able to reset our projectile if the projectile collides with the target, right, Larry?
Right, we want to be able to immediately put the projectile back into a ready-to-fire state.
And what is a ready-to-fire state? Basically, if it has traveled off screen, right?
Right, if it has traveled up above the top of the screen, then it can be refired.
So we're going to keep this as simple as possible because we're not dealing with creating and destroying objects here. So for reset projectile, what are we going to do? We're simply going to move it off screen, above the screen. And guess what? It's reset. Reset target, what do we need to do with reset target? We need to move the target back to the top of the screen and set its velocities for movement, right?
Right, and you'll notice there's a slight difference here where we have 2 methods dealing with the projectile, fire and reset. We only have one dealing with the target. This is because the target doesn't have any other state than moving down the screen. The moment he's destroyed, the game spec said that we were to immediately have him respawn at the top of the screen and refire in a certain
That's right,
direction.
and he's moving again in a certain direction, a random direction. The funny thing about when we do the reset projectile, when we move it above the top of the screen so it's out of view, it still moves. The timer keeps on moving it. As a matter of fact, Logan, we were talking about that, and you whipped out a calculator to figure out how long it would be before the integer that holds the value of its position caused a problem because it became too large of a number. And how many days was it?
I think I had something like 35 days.
Like 35 days. Just for those of you that are thinking, well, if it's constantly moving, that means that position's getting bigger and bigger and bigger, and you're going to finally get to a point where it's too big of a value for what that variable can hold. Yes, you're absolutely right, but you'd have to let the game run for about 35 days straight. So anyways, moving right along. These 3 methods are going to make up our primary gameplay methods. Now we do have some other important methods that we can put into a category of their own, and these are going to be our collision methods. And what do we have in our collision methods? We have 2 things to check for, a ground collision and an air collision. So check ground collision. And then we've got check air collision. Check ground collision is just going to check to see if the bottom of the target has touched the bottom of the screen. And if it's done that, guess what? We failed to kill the target before the target hit the ground. And then that's where we got to worry about everything else involved with, taking away a life, etc. But we need to be able to check for that. Check air collision, what's that checking for? That's checking to see if our projectile has collided with the target, meaning we have actually hit it. Hooray. So we need these two collision methods. What else do we need? Well, we're going to need a utility, or actually a couple of utility methods. All right, let's go ahead and give ourselves just a little bit of room here. I knew that was going to be coming. All right, so utility methods, we're going to set up two methods that provide a little bit of work for us, a little bit of calculation, and give us a result back. One of the things that we need is get center. So while I write this out, Logan, you want to explain?
Okay. What it comes down to is inside of check air collision, we of course need to be able to check whether or not our projectile and our target have collided. The way we're going to make that decision is based on how far apart they are. That means we need to be able to measure the distance between our target and our projectile. Mm-hmm. Now, that may seem simple at first, but you've got to think about what we're dealing with. We've got things like top and left and bottom and right on our objects, but they otherwise behave like rectangles. And even if we took the top left points and compared those, the problem is we're doing a check to see if the top left points have collided, which will look weird. It will actually allow the projectiles to half phase through each other. It's basically like the collision will be offset.
Right.
We need something that will give us a point located at the center of either our target or our projectile. And in this case, it would be most convenient to have a method take in a control, because that's what picture boxes are. They're controls.
So here's a control, and we can hand that control into a method, my graphical representation.
And then that method's going to look at that control and return a point which would reside in the center of that control.
So we're going to get an XY basically back that's going to represent the center of the control.
And what that will allow us to do is, because our target and our projectile are circular shaped, that would allow us to give what would look like a visual collision, because if we're allowed to measure the distance between two controls from the center, and it looks like we're colliding two circles, then we can just do a simple distance check. And we know that if the distance between the two is less than a certain value, then visually the two objects have collided.
I'm just drawing out all of these cool pictures right here. So not collided. Collided.
So that way we have this collision down to a simple distance measurement.
There you go. All right, I just thought I'd throw a few extra things in there while you were talking. So there's some supporting graphics. Basically, I added the note over here of take in a control, this particular method, and then return a point located at the control center. All right, so now the next thing we're going to do to add on to this is, as Logan was saying, we need the distance.
So we're going to write a method that will take in the 2 points we gathered with the getCenter method, take those 2 points and compare them in a way that will return the distance between them. So we're going to need to do some comparisons between the exact points locations using the distance formula. And that will return a value, and that value is how far apart those 2 points are.
So I'll just say it returns a distance, like such. Okay, so that is going to be our utility methods. All right, let's see, how much more room do we have? We're about halfway there. All right, so at this point, let me come right about here. Let's see how much more of this we can squeeze onto here. So now at this point, I think that's got everything set up as far as our skeletal methods. It's time to go ahead and get the gameplay mechanics in. Because remember, this whole section right here was just setting up the skeleton for these methods. That's all. And in our implementation plan, we've now defined pretty much what their names are going to be, and we know what they're going to do.
Right, we've defined all the interactions. We've defined how everything moves and how it interacts.
Exactly.
Now we need to take this and make a playable game that can begin and end.
So now we're going to look at gameplay mechanics. And what gameplay mechanics means is basically we're going to create a playable game. We'll be able to move our player around, fire, and hit the with the projectile, hit the target, have the target respawn. Simple enough, but we don't have our gameplay in place. We don't have our rules in place where we have our player that we can then kill off, game over, clicks, to start again. We don't have that in place.
We don't even have lives yet.
That's right. This game mechanics. We can move, shoot, destroy target respawn, or we miss target, we shoot again. Okay? So to do this, so now it's back to having a little bit of fun. So a quick recap, not to bore anybody, just to jump back up. So, but not by doing that. So moving back up over here. Where did we have fun? Well, we had some fun here because we created some objects. Then that wasn't really all that fun. Then we came down here and we made the player move around with the mouse. Well, that was pretty fun. Then we had some fun here because we added a timer and we got to see our target move and our projectile move. Then it got boring for a little while because we created all of these skeletal methods. Now it's time to start having some fun again. Hey, like my interesting way of defining what we're doing. So for this case right here, the first thing we need to do is make it so that we can fire the projectile. Because remember, we can't fire the projectile right now. What did I say? When we start the game at the moment, the application runs basically, what does the projectile do? It just moves up and off screen. So there it goes, moves up and off screen and disappears. That's it. We can't actually fire it. Yes, the skeletal right here, the skeleton's in place for it,
and
but
just to
no
reiterate,
code in it.
Yeah, just to reiterate, what we mean by skeleton is methods that don't have any code in them.
Just like like Hyperion.
The goal there was to have the methods defined so that we can use any method in any other method.
That's
we
right.
don't have any methods that don't exist yet.
We won't get any compiler errors. We can actually say, well, when this happens, we need to reset this and reset that. And we can call upon reset target or reset projectile and not have a compiler error, even though there's no functionality actually coded into those methods. As we go along, we'll slowly start adding functionality in.
It makes it a lot easier to focus on things one method at a time without worrying about anything else at that time.
Precisely. So back down here to the having fun stage. So gameplay mechanics, first thing, like I said, make it so that we can fire. We can fire. So whatever code's involved to make that happen. So now what do we need to do? Well, continuing on with the fun, we need to check for ground collisions. All right, and of course, if we have a ground collision, now we need to be able to handle having our target respawn. So that means at this point we're going to have to come in there and code in target spawning. All right, at this point things really start to kind of come together. So now basically what's going to happen now when we start working with these two guys, we're going to come in here. So we can fire. Cool, that's good. Of course, if we fire this guy right here, what's going to happen if our projectile just happens to be lined up right with our target object that's coming down? The projectile is going to go right through it. It's not going to care in the world. Then we move on down here to check for a ground collision. And in check for ground collision, all we've done is basically taken a target that can move down, ting, 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 and we've identified that we've come into contact with the ground. Now we follow that up with code in target spawning. What happens now is it comes down, hits the ground, spawns back at the top, hits the ground, spawns back. So now it looks like we've got this vertically scrolling marquee of a target. But it's not like lives are being taken away. We haven't done anything with lives. We haven't even defined what lives are. We're not able to actually hit it yet with a projectile. Projectile just go right through it. The only thing it's aware of is a collision with the ground, and it knows that it needs to respawn back at the top.
Right. All we've done at that point is gotten the behavior for the target down.
So after that, what we need to do is make things a little bit more interesting and go ahead and code in our projectile and target collision. And at this point, with projectile and targets colliding, we already have the code in place to respawn our target back at the top. Fantastic. But we're going to need to have some more code. We now need to be able to code in the ability to basically have our projectile reset. So now when we fire and we come into contact with our object, with our projectile, now what's going to happen is we can have our target object respawn from the top, and we can go ahead and take our projectile and move it off screen. Of course, the timer is going to keep making it move, but it's now above the screen, meaning we now can fire again when we go to fire. Now, in pulling this off right here, this guy, this is where we're going to have to start implementing things like dun, 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 getting the center of our two guys, getting the distance between them. So this is where things are going to heat up. In fact, this is probably the most sophisticated area in the game. Wouldn't you think, Logan?
I would, because we've got to do the math for the distance check, and we need the utility for getting the center of the control so we can do an accurate distance check.
Precisely.
So it's going to, the most code is going to revolve around projectile and target collisions, because we've got so many supporting things that have to be in place.
Right. So after we get all of that done, let me think. You know what? Just from an implementation plan, that's our gameplay mechanics. We should be able to play the game, though it's not a game. We should be able to just move our player back and forth, fire, miss, and then wait till our projectile goes off screen and then fire again. If we hit our target, the target's going to look like it's been destroyed because it's going to respawn at the top, and our projectile is going to look like, well, it's been destroyed, even though in essence it's just been moved above the screen, and we can fire again.
Right, and like you're saying, we can play the game at that point. It's just it doesn't have a determinate start, and it never ends.
Exactly. So, next major area is going to be the gameplay itself. Gameplay. What do we need to get in place for gameplay? Well, the very first thing, we're going to need to create two new objects. We're going to need to create a title screen and we're going to need to create our lives display. Alright, from here, here's how I'm going to do this. Let's just follow it all the way up to here to continue. Alright, because I'm out of space and can't scroll down anymore. So we've got a title screen and we've got our lives display. Once again, picture boxes that we're going to use. A picture box that's going to be our title screen, and a picture box that we're going to use for our lives display. We're just going to control how much of it we show you to show you how many lives you get.
Right, we're going to do the lives display in a clever way, because the nice thing about that is, for one, it's relatively easy to implement, and it was also easy to make it work on more than one platform. It's easy to port over to XNA.
Exactly. Okay, so with that, what are we going to do next? Well, we need some more variables. So let me find my pen. There it is. So more variables. Again, I'm addressing the important things. So we're going to need something like a bool that's going to tell us, is game running? Why is that important? Well, if you're sitting there at the title screen, it's going to say click to begin. And if you're not sitting there at the title screen, that means you're playing the game. So if you left click, what's supposed to happen? You're going to fire a projectile, if you're allowed to fire a projectile. So we've got two different states the game can be in, whether the game's running or it's not. So the left mouse button is going to do two different things depending on the state of the game, right?
Right. Because, again, like you said, the only trigger or click input that we have is just the left mouse.
Exactly.
So a click to begin has to begin the game versus a click while the game is running has to fire the projectile.
And just while you're talking, I'll add in this was a bool. Lives will be an integer. Now we're going to introduce the concept of lives. We need to be able to store how many lives do we have. Start out with 3 lives, and we can, well, lose lives each time that the target hits the ground. And also, let's introduce one more. How about level? Level's not going to be anything that you're going to visually see, but you're going to see the product of level. Each time you actually hit the target as it's coming down the screen, Well, what we can do is increment our level, and we can use level as part of the formula for calculating how fast we need to move the target down the screen. So as we continue to hit the target, we keep taking the level up, the target keeps getting faster and faster.
So you could almost think of it like a difficulty level.
Exactly. All right, so once we have that in place, now we need to come in and do some more skeletoning because we've got some new methods that we're going to add in. So again, I'm just going to go ahead and write out create skeletal methods. Now that we have things like is game running, a variable like that, lives, level, now we can start implementing the true gameplay methods into this, such things as begin game or end game. How about kill player? How about kill target? Okay, so that's pretty much what we need to get skeletoned in. Again, empty methods, but the framework is in place that we can then go in and start adding code. So now we need to go start adding some code in. So the next thing is going to be allow player to start the game. We need to be able to track our lives. And end game when we run out of lives. So we can say in end game. But that is end game when we run out of lives. And then the final thing for our implementation plan is we need to be able to display the number of lives and have that functioning properly. Display number of lives. And there you go. This is our implementation plan for Canon 1. This is our roadmap that is going to help us get things coded quickly. So I would highly recommend that you take notes. You jot all of these things down. Hopefully you were doing that as I was jotting it down. And then follow along as we begin coding the game out, and you'll see how we're going to use this as a map for what we need to do. Again, we're going to simply start out by creating those objects, defining some constants. We're going to make the player, so first things we see, make the player move with the mouse. Add in a timer so that our target will move, our projectile will move. Create a bunch of skeleton methods that we can come in and slowly start adding some code in. Once we got those in place, then we're going to begin with our gameplay mechanics. This is where we go back to these methods and we start adding code in so that we can fire. We know when a collision happens between the target and the ground. We can respawn the target back up at the top. Then, the complex one. Now we can go ahead and check to see if our projectile hit the target. And if that happened, then we need to be able to reset our projectile. Of course, we also need to reset our target, but that's already set up for us. And then once that's in place, again, like I said, we have the gameplay mechanics functioning. Then we need to simply turn our focus over to gameplay. And in gameplay, we're going to start putting all of the gameplay aspects into the game. Title screen, lives and display, set up some variables that allow us to know if the game is running, how many lives we have left, and what level we're currently on that we can use for controlling the speed or the difficulty of the target moving down the screen itself. Then we'll go ahead and move over to creating the new skeleton methods for the game itself. Again, for gameplay, begin game, end game, kill player, and kill target, which will actually force us to change our code around slightly, but I do believe it's going to make sense when we actually do it, because now we have things. The reason we're going to have to change our code around is, well, when we were dealing with the gameplay mechanics, we didn't have things like lives and the ability to end the game, etc. Now we have to get that worked into the framework that we've got set up. And then finally, we need to allow a player to start the game. We need to make sure we're tracking our lives in the game when we run out of lives, and while we're doing that, make sure our display of lives is handled properly. And that, ladies and gentlemen, is Canon 1's implementation plan. Okay, anything you want to add, Logan?
Nothing other than that, with this plan in place now, we've got a very solid idea of what we're going to be working with before we even write a single line of code in Visual Studio.
Yep.
We know what we're doing now.
Exactly. And we are going to follow this plan as we begin coding in the next video. So what we're going to do is we're going to break things up. The next video is going to focus on the actual gameplay mechanics. So we'll just end up probably calling it like Phase 1, mechanics. So that is going to wrap up this video. Thanks a lot.